Hello, everybody. Welcome to this webinar. We are going today to talk and teach you about the next generation functional water repellency technologies. It will be a 30-minute presentation, at the end of which you can ask questions. You can ask questions throughout this webinar. Just use the question and answer button at the bottom. Don't use the chat function, use the question and answer function, and then we will try and answer all your questions at the end of the presentation. Here to introduce you to this new technology, this upgrade, is Lee Howard. Let him introduce himself, and I will see you at the end again in the question and answer section.
So good morning, everybody. Thank you, Rahel, and thanks everybody for taking the time to join us on our session this morning. I appreciate everyone's got very busy schedules, most likely full with back-to-back Zoom conferences. So again, I really appreciate the time taken to share with us today. So if I go ahead and hopefully I can share my screen without any trouble with you, and we can.
Looking good.
Very good. Thank you for confirming, Rahel. That was a good start. So thanks very much again for joining. And again, good morning, everyone, and certainly good afternoon for everybody and for our visitors from Asia. My name is Lee Howarth. I'm working in the strategic marketing team here at HeiQ. And I'm very happy to talk to you today and present to you today some exciting new technologies that we are bringing to market, essentially upgrading our portfolio, our current portfolio of non-fluorinated PFC-free durable water repellency for textiles and leather. As Rahel said, the presentation should take around about 30 minutes, and that should give us about 15 minutes for a Q&A at the end. But feel free throughout the session to post any questions you have with the chat function, and hopefully that will give us enough time to field your questions as we get to it. Okay, I think with that we can start. So I think firstly what I'd like to do is just to give a short overview of who we are. Let me tell you a little bit about HeiQ themselves. And really we'd like to think of ourselves as a kind of innovative innovative company, but in a disruptive and a sustainable way. We position ourselves really as a leader in textile innovation, creating what we believe is some of the most effective and durable high performance textile technologies on the market today. Essentially, we see ourselves as a 3-in-1 company. On the one hand, we're doing scientific research through a kind of boundless research network, with partnering with extensive collaboration with universities and institutes around the world. And this allows us to be really the leader in creating novel chemistries for textiles. We are also specialized in the manufacture of specialty chemicals and materials for the textile industry. And we have production facilities throughout the world and in the key producing regions. And finally, importantly, also, we see ourselves as a marketing company where we really can excel at bringing our technologies to the consumer through an effective ingredient branding communication platform. And this provides the communication of the benefit and added valuable in a very tangible way that the consumer can understand. So really our purpose is to improve the lives of billions of people by trying to perfect the everyday product of the textile. Sustainability is really at the core of our business at HeiQ, and sustainability doesn't mean just economic, environmental, and social principles, but of course is how we do business. And here are really some tangible examples on the screen now, and recognitions of those examples of exactly that itself. We simply aim at trying to make textiles better, developing technologies that reduce impact, using recycled materials, using bio-based or biodegradable materials to help ensure that the product's life cycle leaves minimum burden to the environment, ultimately reducing the consumption of our natural resources in the manufacturing process and throughout the final product's lifetime is really the goal. So we're quite fortunate at HeiQ. We've been able to deliver quite an extensive number of innovations over the last 15 years. We have essentially 9 product families, 9 product categories. And today, of course, we're going to talk a little bit more in depth around Eco Dry and the evolution of the Eco Dry technologies. So let's just take a step back first in terms of trying to understand, really what is the issue. And I think we're all probably very familiar with the transition that's been taking place in the industry over the last few years, but it's good to have a look back at where we have come from. And actually, when I put this slide together, I was quite amazed to realize it was almost 10 years ago that the pressure was started by the NGOs, particularly Greenpeace, on the brands, catalyzing or igniting this start of this transition. And this was as part of the broader detox campaign from Greenpeace, where they issued a series of reports, Chemistry for Any Weather, targeting the use of PFCs in the outdoor industry with a clear objective. And that clear objective was a complete transition away from the use of PFC chemistry in that industry. And to a large extent, it's probably clear that that goal has been achieved, but it continues today way beyond that. Here's an example of the current restrictions, for example, in Europe, in the EU. And this has partly been driven by those brands' commitments to ZDHC as a consequence of Greenpeace detox campaigns and these Chemistry for Any Weather reports. But secondly, the ECHA, this is the European Chemical Agency's regulations, which essentially have been enforced since July last year, and essentially limits the permissible presence of the side substance in the use of PFCs, which is the PFOA, and its salts on the textiles themselves. As I said, this has been enforced since July last year, and there is a further transitional period for protection fabrics and medical fabrics. So essentially, that's already further restricting the use of PFCs. What we're likely to see going forward is further regulations within the EU. Again, driven by ECHA, and this is a proposal ECHA put together for the restriction of so-called PFHXA, the perfluorohexanoic acid, its salts and its related substances. And currently, actually, where we stand as a decision is pending on that. That followed the industry consultation period, which ended through September last year. The scope of this restriction is quite extensive because it will cover not only the manufacture of those products, but the import and use of those substances within the EEA area. The decision for this, or the final decision for this, is actually due in a few months, mid this year, and with an expected transitional period. There will be certain derogations expected for specific end uses, but that is yet to be determined. What this actually means is that there'll be a significant impact on the use of fluorochemical-based products within the EEA. And essentially, this will provide a de facto ban, an effective ban on the use of those products in the market. And that's due to essentially the restrictive limits that are being placed on exempt articles, preclude then the use of alternative chemistries to PFCs. Important to know is that these limits here, there's a 25 ppm for the salts and 1000 ppm for the related substances, also apply to the articles that are placed on the EEA. So that's including imported garments. So clearly this is going to influence major supply chains certainly from the global brands and retailers who are working across multiple markets. So again, this transition from PFCs to PFC-frees really does influence or is influencing the whole value chain. Of course, instigated, as we said, by the NGOs, supported then by voluntary schemes, and now government and regulatory legislations coming in place to can further enforce that. So really supporting the brands and the producing mills with credible alternatives to PFC chemistry is the challenge. So just looking a little bit more at that challenge, it's a complex transition. Let's not hide from this fact. The transition from PFC to PFC-free is a complex undertaking. And again, that's been driven by the NGO and public pressure, local and regional restrictions, as we've outlined. But at the same time, brands and importantly, the consumer is still looking for performance. They demand quality, safety, functionality, reliability, and durability of their products. So there's no compromise that can be accepted with regards to performance. And then on top of that, it's increased complex alternatives that we are navigating to, the technology shift from PFCs to PFC-free is a significant undertaking, primarily because of the complex differences in chemistries that are involved. We're moving from one class of chemistry, fluorinated substances, to PFC-free, which can be multiple chemistry bases and multiple options. So again, it's important to understand how that impacts the final product and the aesthetics of the fabric itself. So really, this talks to that a little bit here in terms of that complexity. PFCs have much higher efficiency generally at lower amounts. So we've seen this over time, that generally higher loading levels are required PFC-free versus what we traditionally saw with PFC chemistries. Of course, that also impacts other aesthetics or secondary aesthetics, such as coating adhesion, as we see here, lamination, bonding strength, color fastness, shade, handle, and ultimately cost impact. And again, this talks quite elegantly, where it's quite a detailed slide, but the purpose there is really to, again, demonstrate the complexity of this transition. We're moving from this one class of chemistry where it's just fully understood to different alternatives that all provide a durable water repellency on the one hand, but have differences in aesthetics and performances as well. So again, understanding how we navigate through that is the key challenge. In addition, there are problems that are known as well and have been encountered. Are classic problems that continue to be seen with the use of PFC chemistry or PFC-free chemistry. Seam slippage, bonding strength, particularly for multi-layer fabrics where coating, lamination, seam bonding, transfer printing becomes more challenging now as we move away from fluorochemicals. Chalk marking now starts to become more of an issue as we see increased loading levels and the different chemistries applied. Roller buildup as a consequence of those chemistries and those polymers. And of course, then the different chemistries then provide different handles. So the solution really, we believe, is Eco Dry. This is the portfolio or the family of products that HeiQ continue to evolve to provide credible alternatives to PFC chemistry for both textile and leather applications. And really, this is based on nature, and we'll see that shortly, bio-inspired technologies, really with the goal to keep those garments and footwear ecologically dry throughout whatever conditions or whatever applications that they're used for. So of course, for example, they need to be extremely efficient. It needs to have very high durability to washing or dry cleaning or durability to use, and very high performance for, as we see here, for washing and durability can be achieved with the appropriate product selection. And interesting, more importantly, these days with the rise and the relevance of hygiene finishes such as antimicrobial, antiviral finishes, the compatibility, the co-application of these finishes becomes critically important. And I think we've seen that over the last year or so, the challenges in bringing these kind of technologies together without compromise has been somewhat problematic. Again, hopefully that should be, we'll see some examples of how that's been resolved now. And again, really what we're trying to do here is really retain the natural aesthetic of the fabric, the material, the leather, and of course then improve in the abrasion resistance. So really how that works is essentially, and the classic model here is, whatever the chemistry and whatever the approach, we're looking at reducing the surface tension of the substrate itself. And that allows us then to minimize the contact area, provide a very high contact angle between, in this case, the water drop and the fabric, creating this so-called super hydrophobic properties. And that can happen by a couple of generic mode of action examples, as we see here. On the left-hand side, we see creating structure is a very elegant way of minimizing contact point, creating structure on the surface. We get essentially a physical minimization of contact points between the substrate and the substance. Or the other alternative is to really look at what we call sort of steric hindrance, where we're looking at these kind of tightly packed functional polymer units in this case, where we're really creating a physical barrier to penetration. So these are kind of the classic examples of how that kind of works. So the HeiQ Eco Dry products are really designed for a very wide range of apparel and footwear and other accessories, and we see some examples of that, particularly on the textile side, outdoor industry, outdoor jackets, windbreakers, hiking, ski wear, and so forth. Clearly, where the need for high performance pinnacle applications for water repellency is key. But more and more, obviously, also into fashion wear and we see that footwear as well, and equally on leather. The challenge there is really understanding how to navigate through those end use requirements, end use needs, and product selection. So here, what we've tried to do here is to sort of say, look, I think it's very important to recognize that product selection starts with understanding the requirements at the end use itself. What is the end use? What is the end product looking like? What is the construction of the end product? And kind of work your way back then to identify and work with the most appropriate chemistry. And I would say that's the biggest change that we've experienced with this transition over the last few years, where kind of the chemistry itself was kind of pre-selected. PFCs were pretty much robust enough to work across different applications and different requirements. And I think we have to change that mindset now and look at really start with the end product and backward integrate the most appropriate chemistry for that product. So again, this is what we've tried to do here is select the most appropriate products for the different end uses. So for example, outdoor apparel, we talked there about ski wear, mounting wear, outdoor jackets, windbreakers, etc. Two key products here, the Eco Dry Syn, Eco Dry Cell for cellulosics, Syn for synthetics, would be the kind of the pinnacle or the cornerstones for those applications. Fashion apparel where different requirements may be needed, so maybe handle, maybe it's more sensitive fabrics, more laundry air dry capability may be needed, durability to dry cleaning and so forth. Again, this would be a different product selection that we would be advising there. And again, leather, here we have a new product where we really have hopefully fulfilled some of the significant performance requirements that's needed in that field. And these are augmented and supported by so-called technology boosters, again, specifically designed to help optimize the application, optimize the concentration of the product that's required, and ultimately supporting the improvement in performance. So I'm going to talk a little bit more in detail about three products in particular, the three new products which we've highlighted here, the Eco Dry Syn for synthetics, the Eco Dry Cell for cellulosics, and the Eco Dry LED for leather. So let's start with the Eco Dry Syn. This is the high performer for synthetics. So Eco Dry Syn has been developed again specifically for use on synthetics and their blends, and really the target there was again to achieve this exceptional high level of durable water repellency, but having this very important and certainly going forward continues to be very important combination capability, compatibility with antimicrobial finishes such as the HeiQ Viral Block antiviral technology from HeiQ, or the HeiQ Pure Tag, the antimicrobial technology. So again, that was the real key challenge there that we looked at developing this product without compromise on efficacy, DWR efficacy and durability. So this provides us this capability, provides a very soft handle. Again, laundry air dry performance is capable, again, selection with the most appropriate booster technology allows us to cure that at low temperature and achieve this laundry air dry performance as well. Also supporting then the need for reduced chalk marking, reduced delamination, and reduced roller buildup. So again, this is really fits within the constraints of what we were looking for. So I'll give you some examples here of the next few slides of that kind of performance. So here what we're showing here is the bacterial reduction performance, the log reduction performance. So this is the colony forming units of bacteria that's reduced over time from the antimicrobial. So here we have the HeiQ Eco Dry Syn together with the viral block MPJ03, and we see here the initial 10 washes and 20 washes, a fairly consistent log reduction, high level log reduction above 99.9% reduction. So again, combination of the two on this polyester elastane really has no negative influence, as we've been seeing with regards to efficacy over multiple washes for the antiviral technology. And again, this is a good example here, explaining that, where we've been able to benchmark that against kind of current standard products, the orange and the light orange bars there, I would say, versus the HeiQ Eco Dry Sin, the green bar. And again, consistently high level. This is on a polyester treated with the DWR product and the ViroBlock in this case. And again, a consistently high level of antiviral performance, antimicrobial technologies above 99.99% in this case. Again, after 10 washes without any tail off, as we would classically see there with the conventional chemistries. So again, this has been a real positive boost there. But of course, it's not only about that. It's obviously we need to look at the repellency as well. And I always like the results we get, or any performance evaluation using Bundesmann. This is the rain test, and I think most people are familiar now with the Bundesmann test versus the spray test. I like to say this kind of separates the men from the boys a little bit. This is replicating really quite a severe tropical rainstorm, if you like, over an extended period of time. So really does provide extensive evaluation capability and assessment for repellency from a visual point of view, from an absorption point of view, that's in terms of the weight gain of water on the substrate, and ultimately from the penetration point of view. So you have three clear metrics that you can measure from that. And again, what we're able to demonstrate here is that over time, over the period of the test, and after multiple washes, that we're able to achieve a very high Bundesmann performance rating with the Eco Dry Sin, again in combination with antimicrobials in this case. So moving on to the next new innovation is the Eco Dry Cell, and as the name suggests, that's clearly targeting for cellulosics. And here this is a highly effective fluorocarbon-free sustainable water repellent agent specifically for cellulosics and their blends. And again, obviously, this is targeting very high hydrophobic properties. And when we talk of hydrophobic properties, we're not only really considering water there, but also clearly water-based stains and a broad spectrum of everyday stains that may be subjected to by the user. So again, we have to consider, as we navigate away from fluorine to non-fluorine, obviously the challenge around oil management, oil-based repellency becomes more problematic. But of course, it's not only about water repellency. Everyday stains, and many everyday stains can be repelled as well. So here, we have a really high level of DWR performance, which is extremely durable to washing. Typically, the challenge on cotton, on cellulosics, is the durability, and the next one as well, the sensitivity of residues on the textile itself. And I think this is kind of pertinent to really the key learnings as we've navigated from PFCs to PFC-frees over the year. It's really important that we understand the entire textile wet processing to optimize the appropriate finish as well. So ensuring that the fabric is free of residues, free of any contaminants that may have a detrimental effect on the DWR finish is critical, much more so, I would say, than historically we would have seen certainly with C8 chemistry, probably less so with C6, but certainly versus PFCs, it's more significant. So again, not to be underestimated. Again, developing products that have low sensitivity is very important. Again, low risk of delamination. Obviously, it's free of organic halogens and fluorochemical chemistry, as well as APO and solvents. Important, non-flammable, particularly on cellulose. So again, can be combined with appropriate FR products for different applications without challenge there. And again, one of the major issues with PFC chemistry was the flashing tendency in combination with FR chemistry. So again, we were able to overcome one of those key challenges in the past that we've seen with fluorochemistry. So here we have sort of the classic example of performance on, this is a cotton jersey, 100% cotton jersey treated with the Eco Dry Cell. The spray test, the AATC 22 test method. And here we see our previous product, and again, we've been able to further boost that performance with regards to spray rating, the green versus the orange over initially, but also over multiple washes. But I think probably more telling is the wet pickup. This is the AATCC 42 test method, impact penetration test method. And again, here we're measuring the absorption of water on the substrate as well. And we're able to see a significant improvement there in that positive wet pickup of water over time versus older chemistry. So again, significant benefit there with regards to durable water repellency performance on cellulosics. And then moving on now to the kind of slightly, obviously more tailored towards a different industry, but this is the products for leather, the Eco Dry LED. So really, we developed this as a kind of top performer for LED, really looking for obviously water repellency, primarily targeting for non-washable materials. But here the challenge is to achieve this high level of water repellency with alcohol repellency efficiency as well, and really combining those two without any use of fluorine chemistry is a major challenge. Without doing that, also without leaving any water marks or water halo marks, again, has been which has been seen as problematic. Again, we've been able to overcome that with this new product. Not influencing the aesthetic, the soft hand feel of the leather, high color consistency here. So we're getting excellent LAB values with tone on tone. So for the tannery, again, very helpful with regards to tone on tone application, and managing that with, at least from the dye master's perspective, supports ease of use there. And again, free of any organic halogens, APO, and solvents, and ultimately non-flammable in addition. So again, some examples here on leather with the Eco Dry LED spray rating on the one hand, but also this high level of water alcohol, or the alcohol rating, rating of 4 on both those two there. So really providing excellent water repellency, and again leading to this no or reduced chalk marking tendency, water marking tendency on the leather good itself. So some examples of the Eco Dry in the market today, and again, we've been working, HeiQ work globally with the major brands around the world, the major specifiers for the chemistry, again, the leaders in terms of technology nomination. So again, we've got some very big programs where you'll find the use of the Eco Dry technologies are communicated, both on apparel, outdoor apparel, but also on footwear, as we see here. And again, we're very confident with the new product, particularly on the footwear side, the new Eco Dry LED being adopted. We already had one of the world's largest leather footwear brands adopting the Eco Dry LED as an alternative to short chain fluorochemicals as the next step, and that's happening as we speak. So already immediate success and immediate verification of the performance of that product. And again, that's supported somewhat by our capability there to help communicate. And this goes back to what we talked about in terms of HeiQ as a capability to market, communicate the technology to the end consumer. And here's some examples of that from O2O communications, offline to online communications through the hang tags themselves. We have permanent labels, flyers, again for more B2B applications. Again, graphical illustrations can help communicate videos, and many more supporting communications, helping to communicate those relative benefits to the end user and the consumer. And again, this is in line really with HeiQ's strength and commitment to helping communicate technology to the end consumer and the relative value of that. So supporting that is so-called ingredient branding. So in this case, HeiQ ingredient branding, HeiQ Eco Dry ingredient branding is supported by a hang tag, whether it's for footwear, the smaller one for footwear, or for apparel. And that involves essentially the process for that is essentially getting the fabric validated, quality validation through the testing, and that has to be tested, and then ultimately the fabric or the substrate, the leather, has to meet HeiQ's minimum passing criteria for a specific product. And then we work with the end users on trademark licensing to ensure appropriate communication of that going forward. So I think with that, we're pretty much on time, Rahel, with the presentation. I think that brings us to the end of the formal part of the presentation. And I think maybe that probably provides us sufficient time now for some questions if there are any already posted.
Yes, thanks, Lee, for the presentation. You were really just as you should for the timing. So we have time for questions now. One of the questions I'll just answer myself. It's already asked, will the recording be available afterwards? Yes, it will. I will send out viewing links latest next Monday, so you will be able to rewatch this presentation. And now to Lee. The first question for you, there are so many companies with comparable water repellent products. So why should we choose HeiQ Eco Dry? Is a challenging question.
Good question. Yeah, exactly. I would ask the same question. So again, this is part of this challenge as we see this complex landscape that has evolved now since during the migration from PFC to PFC-free chemistry. There are many different chemistries. I think the last count, there's something way over 100 chemical suppliers that are known providing DWR chemistries to the market. But I think it's not only about the appropriate chemistry. I think clearly working with companies such as HeiQ that are able to identify the challenges, working with really innovative companies that can deliver solutions is clearly important. But I think it's more than that. I think it's working with companies who really fundamentally understand the broader challenge, and it goes way beyond just a DWR treatment or just applying a DWR chemistry. And I think in this case, that would be sort of my biggest takeaway from this whole transition has been, we need to look at the application of the DWR more holistically. What the whole process of the dyeing process, the pre-treatment process, ultimately the finishing process needs to be looked at as a seamless review to optimize the treatment, because ultimately those problems will come back. Those problems around handle, chart marking, cost, poor performance. Ultimately cost of clearly where chemistry is used at a higher level than probably necessary to offset some of these challenges, needs to be looked at. So what for me I would say is working with a partner who have the broad capability across the different end uses, such as what we've described here, but also the understanding of those challenges and really recommend and understanding how to navigate and overcome those challenges. I think that's key. So that would be my sort of takeaway, that there's a significant difference there in terms of capability, and I think that's where it's important to work with that right supplier.
Okay, thank you for your answer. Here's the next question. How is the performance related to stain repellency of your DWR products?
Well, I think I mentioned a little bit about stain repellency. So again, classically the challenge we're seeing with non-fluorine chemistry is the ability to manage oil. On the one hand, repellency, but also the release of oil-based stains. So this is the kind of the stain repellency. Of course, as I mentioned, water-based stains, broadly are kind of included, are within scope for non-fluorine chemistry, and particularly for the Eco Dry SYN, the Eco Dry cell, particularly the cell on cotton or cellulosic-based fabrics, where it's more challenging for stain release, where we see a very effective water-based stain release capability. I think with all non-fluorine chemistry, it's a bit more of a challenge as we introduce oil-based or fat-based substances within that equation. But I think what we see is that there are selective benefits, selective capability there that is possible. And I think what is likely we're going to see over the course of the next couple of years is an evolution, more focused towards managing stains with regards to release. It's going to probably be a bigger challenge. I'm not to say it's not possible, but it's going to be a big challenge to achieve oil-based repellency without using fluorine chemistry. Well, let's see. That's the hope. That's the holy grail for research. But that's a big stretch. But what we're likely to see, and what's very much in scope, is improvements with regards to durable water repellency using non-fluorine chemistry and improved oil-based stain release. And I think that's more within scope, and we're seeing more of that coming. So to answer the question, stain release, obviously if it's water-based, it's within scope, particularly for those products that are developed for that application. So here I would suggest the Eco Dry CEL or the SYN for synthetics. But then going forward, we're likely to see some further innovations really targeting further effective release of oil during the washing process.
So you have here answered the next question as well.
Okay, good.
Will that give oil repellency too? Not yet is your answer.
No,
so
yeah. It's a fair. That's as I say, that's the holy grail. I think we'd all like to be in a position where we can achieve an oil repellency without fluorine. Right now, there are a number of developments out there, and clearly a lot of research going on. You can imagine also a lot of research that's historically been put into fluorochemicals is now obviously transitioning to developing solutions away from that. So it could be a matter of time, but ultimately this is a stretch. Let's not underestimate the challenge that we face here. That this is a major challenge for the industry, for the chemical industry, to achieve oil-based repellency without using fluorine. But we remain hopeful. Science has a habit of surprising us all, as we've recently seen with the COVID vaccinations.
Okay, the next is an interesting one. It's with synthetic fabrics. Can you quantify performance with air drying? Is it improved compared to other DWR products?
Again, product selection here. So we have product selection, and I think it's the appropriate product on synthetics with the appropriate technology booster here. We can provide a certain LAD performance. Again, classically, I would say most non-fluorine chemistry has challenges with regards to LAD performance, laundry air dry performance. But there are exceptions, and I think we've got, again, this is where this appropriate portfolio of products, depending on the end use, can be more selective. So again, in that case, it may be a case where we can achieve an appropriate laundry air dry performance, but it may not necessarily be the most appropriate product for multiple layers, or if it's coated, laminated, for example. Not to say that's not the case, but again, I think it's important we understand the full picture of the end product and look at the right product selection. So this is why, again, this portfolio of tailored solutions for the different end use becomes very important. Let's understand the end use, and apply the appropriate chemistry towards that. So yes, to answer the question, LAD can be achieved. Again, depending on the application and other requirements, but in general, that is within scope with certain of the LAD products. So we mentioned the Eco Dry Syn has been a good example on synthetics, and also the product I've not referred to, or the two products I didn't refer to is the ACT, which is more silicone based. Again, which may be more problematic for multi-layer fabrics, but certainly for single layer fabrics wouldn't be a challenge. And then the other product would be the SPR, where we're seeing benefits for LAD. So again, there are options there.
Okay, so we now have actually two people asked very specific fabric-oriented questions. I'll just read both. You can answer both in one go. So what recipe would you recommend for 50-50 polyester cotton fabric? And the next is, what would you recommend for polycotton PA cotton blends?
So the second one was polycotton?
The second one was polycotton PA. What's that stand for?
Polycotton PA,
yeah.
Polyamide, yeah. Okay,
yes.
Same. Again, I think it links there to the performance requirements. So if it's a 50-50, logic would dictate that we should use both products, the Eco Dry Syn and the Eco Dry Cell in a combination. Again, we've got a lot of screening that's identified that there is definite synergies between using the two certainly on blends, on a 50-50 blend, whether it's polyester or it's polyamide with cellulosics. But I would say probably it comes back to performance requirements. It could be a case that the Eco Dry Syn, I would tend to start with Eco Dry Syn, and if we're not able to achieve the performance requirement with that, then introduce the Eco Dry Cell into the equation, again modifying the loading levels to compensate. But depending on the performance requirements, you can either use this one or both of those two products. I think that would be the advice.
Okay, quick question. Is it CDHC approved?
It's a good question. So as with all products going on the market now, and certainly from HeiQ, and maybe goes back to my one of the first slides, HeiQ are a system partner for bluesign. So all our products are submitted for bluesign approval. So these products are actually currently in process for homologation with bluesign right now. And we're confident that we'll receive bluesign accreditation. By definition, that means that there's a read across to the ZDHC gateway. So as we all know, the ZDHC gateway is the vehicle for seeing whether the product is accepted by ZDHC, and bluesign is set at the highest level 3 on the gateway. So yes, it will be available via the ZDHC gateway through the bluesign approval accreditation process.
Okay, thanks for the nice presentation. Thank you for saying that.
Very welcome, thank you.
Yeah, is the new technology, does it contain any acrylate-based polymers, and how can you make sure of the eco-friendliness of your products?
So yeah, probably getting a little bit on thin ice with regards to the chemistry now. So apologize if I'm not able to answer that question in the detail it probably deserves. So maybe we can come back to that with a bit more detail. But the chemistry that's used within the different products, there's different chemistries. So acrylate will be part of that solution depending on the product. And again, I think what we have in mind here is the appropriate use of chemistry. You know, very important is the risk that we all face with regards to, just because it's PFC-free doesn't make it safer or necessarily safer or better. So this risk of regrettable substitution has to be considered. And that, again, I think that's very much in line with the ethos of the company with regards to, you know, the appropriate selection of chemistry to meet a performance profile. So in mind, you know, is of course the safety of use and the appropriateness of that chemistry as an alternative. Obviously, it needs to meet those performance requirements and the aesthetics that we are requiring the final product to do, and of course, then the safety use. And I think that the second part of that question, Rahel, maybe I'm not sure if I answered it.
Yeah. How can you make sure it's eco-friendly, as we claim?
Yeah. So yeah, I mean, we of course eco-friendly. The definition of what does that mean? So of course, the appropriate use of that chemistry. Of course, we want to make sure there is no PFCs introduced in that system. So of course, we ensure that supply chain from our manufacturing is consistent with that approach. But I think in terms of expanding that security, if you like, further downstream, I think what is clearly the mill themselves, the companies that are applying those products have to ensure, obviously, that there is a minimum risk of contamination, let's say from PFCs in this case. So there's no risk of presence of PFCs or PFOA or PFHXA in going forward will be more and more an issue. And again, that's coming down to how those products are produced and the housekeeping within the production environment. And we've seen actually over the last few years, particularly in the textile industry, that a number of mills are effectively set up separate manufacturing lines, new manufacturing lines to again ensure that there's a minimum amount of risk of contamination or carryover from any residual substances coming from historical production or ongoing production with the use of fluorochemicals. So this has actually been managed separately, and again supporting this security of use in use. And again, we have to recognize that's important because the levels that we are considering here, particularly for those restricted substances, are extremely low. Parts per billion, very, very low, and it's a very small amount that residues that can be found in production equipment that can be carried over onto fabric. So again, having appropriate housekeeping in production, equally with the chemical supplier working with that approach is very important for that to provide that kind of level of guarantee, if at all that's possible.
We seem to have a lot of attendees who are actually really producing fabrics, so the producer side. So to achieve laundry air drying with HeiQ Eco Dry, do you need a linker? An X-linker, I'm not quite sure how to pronounce it.
X-linker, yeah. Yes, well, it depends on the end product. Certainly, if we are looking for, let's say it's synthetics, we would advise the use of an appropriate cross-linker there that can be used to help boost the performance for laundry air dry. I think it's fair to say laundry air dry is challenging, typically has been challenging for non-fluorine chemistry, and also for fluorine chemistry. There's only very few fluorine chemistries that were able to achieve real good LED performance. But certainly the use of the appropriate cross-linker chemistry can help with the laundry air dry performance. On synthetics, I would suggest that would be what we need to do. If, for example, it's something like where we can use a silicone-based chemistry, so the product I would be thinking about there would be the let me pop back the previous slide actually, so you can see it on screen. So this would be the HeiQ Eco Dry ACT. The ACT silicone-based chemistry. Again, probably wouldn't be appropriate for multi-layer fabrics, but more for sort of cellulosic, synthetic, single-layer fabrics, or more sensitive fabrics like wool, silk, for example. This will achieve a laundry air property here, as you see there by the little diagram, without the use of cross-linker. So again, depends on the fabric, depends on the chemistry, depends on the chemistry that we select. But yes, in general, it can be achieved.
Okay, moving on to the next question. Some questions are pouring in, so maybe so we can answer them as many of them as possible. Let's keep it short.
Okay.
Next one is, which is the maximum level of the spray test that we can reach with the HeiQ Eco Dry for precious fibers?
Precious fibers, I assume you mean luxury fibers like wool, maybe silk.
I'm assuming that too. That was
well, the maximum rating is 100. Again, it's challenging, but it's again linked to residual substances on the fabrics. But the target would be 100, and I think if you can get to a 90 to 100, that would be sort of the minimal expectation I would be expecting to reach to achieve a repellency.
Okay, next question. Does HeiQ Eco Dry Thin have any negative impact on fastness? I'm assuming color fastness.
Good question. In fact, I do have a chart on that on the bigger presentation we have around Eco Dry Thin. So whoever asked that question, we can provide some more details. But very good question. Minimum impact, and certainly versus benchmark chemistries, we're seeing very positive impact on fastness properties and the delta E values. So again, we can provide some more details there.
Okay, next questions. What are the washing temperatures illustrating in your durability graphs shown for thin and cell? Is it 40 degrees or 60 degrees?
Good question. I would have to probably check on that one, but I would imagine that's 40 degrees. I think most fabrics now are washed at 40 degrees for sustainability reasons. Higher washing temperatures gets less and less demanded and less specified by the brands. I would imagine it's 40 degrees. I think to answer the question maybe differently, temperature has a less of a bearing on repellency than actually the mechanical action, whether it's the mechanical action during the washing process or the tumble and drying process. So whether it's 40 degrees or 60 degrees, typically doesn't have a major bearing on performance.
Okay, next questions. What are the types of stains that can be included on HeiQ Eco Dry water repellency performance? What will work as a stain repellent? Will it work as a stain repellent? For example, workwear, shirts, pet textile products, etc.
Very good question about stains and stain management. Of course, when we talk of water repellency, non-fluorine water repellency, we also talk about stain management, water-based stain management. So everyday stains that are of course water-based, we will see a very positive either stain repellency or stain release capability with these technologies. Of course, it becomes a little bit more challenging as we introduce oil or fatty substances within the stain. And I think that's typical for most non-fluorine alternatives, particularly on cellulosics and cellulosic blends. But we're starting to see some more challenges there, some more opportunities there. So I think one of the biggest challenges, excuse me, one of the biggest challenges that we see moving from fluorine to non-fluorine is the ability to manage oil. And over time, excuse me, excuse me, a seasonal flu kicking in. What we're able to see is the ability to manage oil-based substances without using fluorine is a big challenge for the chemical industry. But what we're going to see is more of an ability to manage oil-based substances over time, an improvement in terms of performance with regards to water repellency and oil-based stain management, or at least a certain degree of oil-based stain management. So that's going to see something that's going to continue to evolve over the foreseeable future. But right now, when we talk of stain repellency, stain management, or stain release, this is conventionally water-based stains.
Okay, last question. There are more, but I'll ask one last question in the time we have left. If the client demands a better hand, is it possible to use a softener?
Yes, I would say yes, but it's selectively. I think it's important to understand the softener. Of course, if it's a softener that has hydrophilic properties within that product as well, then of course that's going to have a detrimental effect on repellency. So again, appropriate product selection of the softener without having a detrimental effect also on any subsequent post treatments it has to be considered. But yes, in general, it's certainly a proposition.
Okay, so we've reached the end of our time. We have recorded all your questions, so the ones that weren't answered, we will answer by email personally. Thank you very much. Thank you very much for attending, and bye, and hopefully see you at the next webinar.
Yes, thanks everybody, and appreciate again taking the time to join the session today, and hopefully it's been helpful. And again, we will certainly take the time to answer any of those questions that we're not at the moment to do that. So again, thanks very much everybody, and I wish you a good rest of the day.
Okay, bye-bye.
Thank you.